Let's set up a new neutron probe calibration. Remember how a neutron probe works. It blasts high-speed neutrons into the soil, they bounce off water that have the same atomic mass, they get thermalized or lose energy, and the counter counts how many of these come back having been thermalized. It then compares that with its internal count that it gets in the wax and comes up with a count ratio, which is the number here. And this is a typical range of numbers that you would see. Now, remember that this was in a soil, and if you take that particular soil, do a gravimetric analysis, find the actual water content at the time, you have a count ratio number, let's say 1, which equates to like 2.2 inch per foot in this case. Then you could do that over a span of soil moisture contents and put that on a graph. I did this in Excel and come up with the formula, meaning moisture content y equals 1.559 times count ratio, which is x, plus 0.68. The 0.68 is unusual. Normally the cutoff here is a small negative number, meaning a higher gradient, but this is what this particular instrument came up with. And by the way, when you look at the actual lab results here, remember that a neutron probe is not accurate to the second decimal. So these numbers are really all saying the same thing. Okay, so we have our formula 1.559 plus 0.68. So let's go to the software and set that up. So in probe schedule, you're going to go to soil moisture, and under neutron, go to calibrations down at the bottom. Click on that and you get this screen. This is now showing us the calibrations we already have set up. I have numbers 1 through 4 and the number 9. So let's create a number 5 with this new calibration. I go to the add button, prompts me for the calibration number, and the gradient was 1.559. Our cutoff was 0.56, I think it was. And then if we have a reference calibration drum, that we use, then we would put the number in here. And after having calibrated this instrument for this particular soil, we would put it on our reference drum and we come up with a number. And that number could be anything. And let's assume for the moment that it was 2.35. So this would be a calibration number 5. And this could have been for a specific salt loam on a particular property. Okay, so whatever reminder works for me, and I have created a calibration number 5. Add that to the list. And by the way, when you think of the different soil types and so on, you should have a calibration at least for sand, for loam, for clay, and at least group it into those 3. And then if you have very specific situations like caliche, I would do a specific calibration for that. Or the other one that is important, if you have rocky soil with a very high iron content. The iron, if there's enough of it, will look like moisture, so you need to calibrate the effect out of it. So that's how we added a new calibration. If we wanted to delete it, it's obviously there. If you go edit, you go back in there and you can go and change any of these parameters like this bad writing that I did here. Go ahead and save that, and we have a new calibration. The instrument can keep all of these calibrations. It can do 16 in fact, but then it means the operator needs to remember to change calibrations when it gets to a site. It is a lot better, safer to keep the instrument on one calibration, and then when you bring the data back to the software, convert from one calibration to the other as needed.